Good afternoon. Today we're going to be talking about right triangles, that is, a special type of similar right triangles. Now, with any type of triangle I have, just to set a principle here. So let's say, for example, I have these two triangles. Let's say that they all have the same angles. Now remember, we just dealt with triangles and proving congruency. We couldn't prove congruency with three angles being congruent, but what we can show with that is similarity. So one of the things that we have to understand about triangles is that if I have two triangles that are similar, what I can do then is I can set up a ratio or proportion to basically solve for a side. So for example, if they give me 5 and 6 and 10, and I want to find what this side is. Okay, let's just say hypothetically. So this is triangle A, and this is triangle B. So if you recall from pre-algebra and probably 5th grade math and 6th grade math and 7th grade math and maybe even 4th grade math, you can set up a ratio by saying this is to this as this is to this. So I can say 6 is to 5 proportionately, and then I set it equal to x is to 10. Now notice up here, same corresponding side. And once again, same corresponding side. This is very important. You put the same side on the top and the same side on the bottom. Okay? So triangle A, this side, triangle B, this side. So now I cross multiply, so I get 5x equals 6 times 10. 5x equals 60. You undo a multiply by dividing. So I undo 5 times x by dividing by 5 and dividing by 5, and you get x equals 12. And if you put 12 up here, that kind of makes sense because to get from 5 to 10, you multiply by 2. So if you're to multiply 6 by 2, you get to 12. So now what we're going to be learning about in topic 5-3 are a type of similar right triangle called 45-45-90 triangle. Now notice I start off here with a square. And you begin to ask yourself, Mr. Rhodes, why do we have a square when we're dealing with triangles? They're not the same shape. One has 4 sides, one has 3. But let me show you something really cool. So with a square, we have each of these is a right angle, correct? So if I were to draw a diagonal down the center that cuts it in half, well, 90 degrees by half, I have a 45-degree angle, a 45-degree angle, and a 90-degree angle. So how can I always have a similar triangle? How can I always have a similar triangle with a 45-45-90 triangle? Because basically what I'm trying to find here is that if I see a 45-45-90 triangle and I have one of the side lengths from it, which we'll get to in a minute, I can always have two similar triangles to compare. So for example, let's just set each of these sides equal to 1. Now notice, with a square, all 4 sides are equal, and if I were to divide this in half with a diagonal, then I would have 2 equal sides. So with my good old Pythagorean theorem, I put in my first side and square it, my second side and square it, and say that equals c squared. Okay, pretty cool. Got that so far. So 1 squared is 1, plus 1 equals c squared. So I get 2 equals c squared. Now to undo the squared, I take the square root. And I get the square root of 2 equals c. So anytime that I have a 45-45-90 triangle, and I'm trying to solve for a side, I know that I have a triangle with sides 1, 1, and square root of 2. Now the cool thing is that even if I forget what my hypotenuse here is, because remember I've got a leg and then a hypotenuse, even if I forget what my hypotenuse is, I can come up back here to Mr. Pythagorean theorem. Mr. Pythagoras, brilliant man from back in the day, long before any of us were alive, and I can use his theorem here to solve for it, as long as I know my two sides are 1. So how does this help me for triangles? I'm so glad you asked. Let's take a look at finding the lengths of the missing sides of this triangle. Now if I were to go in here, first thing I'm going to do always, when I see a 45, 90, and that means that has to be 45, whenever I see this type of triangle, the first thing I'm going to do, I'm not going to try to solve anything, I'm not going to try to compare anything. The first thing I'm going to do always, I'm going to draw out 1, 1, square root of 2 on another triangle. This makes it easier. I don't have to do anything in my head. Mental math can be your worst enemy if you're not good at it. So now I'm going to try to find AB. Now this one's pretty easy. I look over here. If this one is 1 and this one is 1, so they're the same length, then these two have to be the same length. And this is 5. Now there are two ways I could then solve for the length of AC, which is my hypotenuse. I could put this into Pythagorean theorem and show that I know how to do something, yay! Or what I can do is I can set up a ratio. I can say 5 is to 1, or 5 is to x, 5 is to x, because I'm trying to solve for this. So my leg is to my hypotenuse as my leg is to my hypotenuse. Now notice, this is my leg, and notice this is my hypotenuse. It's very important that I get that down. I have legs on top, hypotenuse on bottom. Now you ask the question, could I flip them and put the hypotenuse on top and the leg on bottom? That's absolutely, you could. Absolutely. The thing is, you just have to make sure you have both the hypotenuses on the same side of the fraction, and the legs on the same side. So either both tops or both bottoms. I'm going to cross multiply. So I get 5 times the square root of 2 equals x. Just like that. Now, some of you are probably sitting there and watching this, and you're thinking, wait a minute, I see a pattern. Well, that's pretty true. Notice that if this was 5, to get to here, all I did was multiply it by the square root of 2. That's going to come to be very, very important, very, very handy for just eyeballing them and looking at them. So in a 45, 45, 90 triangle, if I have this side over here, if I have one side, I know that I can multiply it by the square root of 2 to get the hypotenuse. Okay? Let's go on to my next triangle. Problem number 2. Now this one's turned upside down, but have no fear. We can still draw out our 45, 45, 90 triangle. 1, 1, square root of 2. Uh-oh. This time, they give me the hypotenuse first. Now the cool thing is that I'm solving for two sides, and I know that these two sides are equal, so really I only have to do half the work. Once I've solved for one side, I have both sides. So let's set these up. The square root of 2 is to 1 as 4 is to x. As 4 is to x. So hypotenuse is on top, legs on the bottom. Hypotenuse, legs, or you could have done legs then the hypotenuse. It's up to you. Cross multiply. X times the square root of 2 equals 4. Now some of you are probably sitting there and you're thinking to yourself, Mr. Rhodes, I have no idea how to handle that. That is a weird square root looking thingy, and I have no idea what that is or what to do with it. Well, square roots, or also known as radicals, can be a little bit scary until you just realize that they're just numbers too. They have feelings just like every other number. They're just numbers. So if I have square root of 2 times x, then I can divide the square root of 2 to solve for x. Remember, you undo a multiply by dividing, and you undo a dividing by multiplying. Think of it like divorce and marriage. These two are married together, now divorce them. So you do the same side. Remember, golden rule of mathematics. What you do to one side of the equal sign, you do to the other. So I get x equals 4 divided by the square root of 2. Now, some of you that remember Algebra 1, when you dealt with these kinds of problems before, are remembering, wait a minute, Mr. Rhodes, we can't leave it there, which is true, we can't. I have to multiply top and bottom by the square root of 2, because it's bad math to have the square root of 2 on the bottom. So why do I multiply it by that? Because I want to get rid of the square root of 2. I want the radical sign to cancel out. So I get 4 times the square root of 2 over square root of 2 times the square root of 2 is 2. Because remember, square root of 2 times square root of 2 equals the square root of 4. Because when you multiply radicals together, you just multiply these two numbers. And the square root of 4 equals 2. So now, can I simplify this anymore? Of course I can. If I have 4 divided by 2, that's 2 times the square root of 2. 2 times the square root of 2. Because they're the same. It's that simple. Now, is there another pattern that we can see here? Yes, there is. I'm so glad you asked. Notice that this number up here is half of this number times the square root of 2. So if I had 8 there, I'd have 4 times the square root of 2. That's just a little pattern as you keep going and you have easy things like 4, even easy numbers. You know, all you have to do is divide it by 2 and multiply by the square root of 2. Or if you want to, you can keep doing it in this form. Let's push on to the next one. Problem number 3. Oh, this is fun. They give us a hypotenuse with a radical in it. Now, before you just throw down your pencil and quit, let's draw our triangle. So 1 square root of 2, and I'm going to solve for a side. So I'm going to say the square root of 2 is to 1 as 3 times the square root of 15 is to x. Looks kind of confusing, but I promise it'll get simpler. So cross multiply. So I get x times the square root of 2 equals 3 times the square root of 15. Remember, when you multiply something by 1, it's just itself. The 1 is understood. So divide by the square root of 2, divide by the square root of 2. Now, once again, can I leave it as x equals 3 times the square root of 15 over the square root of 2? No, you're right, I can't. Why can't I? Because it's bad math to leave the radical in the denominator. Multiply top and bottom by it. Mr. Rhodes, do we always multiply by the square root of 2 over the square root of 2? Well, whenever I have in the denominator, I do. So, I get x equals 3 times the square root of 15 times 2 is 30. And I divide that by 2. Can I simplify that anymore? Not really. Not really. It's pretty good looking. So 3 over 2 times the square root of 30 is my answer. And if that's what it is for one of them, that's what it is for the other. Cool. So now on this one, I want us to try to solve it using our trick. Okay? I want us to try solving it using the trick that we learned. So, whenever I have the hypotenuse, remember, when I have the hypotenuse, let's draw out my triangle. We learned up here in this problem, we figured out that if I take half of this, and multiply it by the square root of 2, that'll give me my answer. So I'm going to do the same thing here. What is half of a half? Well, take a look at it this way. If I have 50 cents, half of that is 25 cents, or a quarter. So half of a half is a fourth, and then multiplied by the square root of 2. And that is my answer. Or square root of 2 over 4. And it's that simple. So that is the 45, 45, 90 triangle section.